And we are live. Hello and welcome everyone to this session about integrating schedule and resources across multiple projects in a complex program management environments. That's a session title that has a lot of complexity to it. So to explain what this all means and how it all makes sense, we have Ted Barth. Ted Barth is a national leading expert in providing solutions to complex program management environments. He's a managing partner of B&W Manufacturing Associates, and he holds BSME degree from Case Institute of Technology. And from his biography, he does a lot of community work. He's involved in with PMI, many other prestigious organizations. So without much further ado, I'm anxious to hear from him and very excited to have him here. So without much further ado, Ted, it's all yours now.
Good morning. My name is Ted Barth, and my background is I spent 20 years in manufacturing and engineering, managing 7 plants in the Midwest. And I began using formal project management techniques in the early 90s in order to get control of major product development projects and major facility projects that I was responsible for, along with my plant responsibility. I founded B&W Manufacturing in 1996, and our main focus is providing project management solutions to manufacturing engineering companies that have complex program management environments, which you will see a lot about today. I've also been the past president of the Great Lakes chapter, or Detroit chapter of PMI, and the founding director of the Michigan Huron Valley or Ann Arbor chapter. So this presentation is a summary of more than 33 years of my salary and business solution provider experience and formal project management. These solutions are considered very advanced with best practices, and many of those best practices, not all, cannot be found in any books or articles, only in white papers I have authored. So when we talk about high performance or high impact, we have defined that as being any major changes in a system, project management system, that can yield a equal to or greater than 15% improvement. So let's take a look at our sponsors. We'd like to thank all of our sponsors for making this virtual events possible. So now let's take a look at an answer to a question on complex program management in the automotive and truck business, where we spend a lot of our time. So this is a key question for automotive capital expenditure. The automotive companies today spend huge amounts of capital expenditure on federal requirements and new models to be competitive. In fact, those capital expenditures cause very low rates of return in their capital expenditure scheme of things. So how is it possible to implement a complex program management environment system using a commercial enterprise-wide technology to do the 3 kinds of things you see on the screen: the time to market improvements, on-time delivery, and many times improvements in resource costs, and especially reduction of overtime? So the reason that I asked this question at the beginning of this presentation, that most people cannot fathom that these kinds of results in a single company environment is even remotely possible. So my goal of the presentation today is to provide you with information to allow you to think differently and allow you to gain some benefits in your future endeavors. So next, let's take a look at defining what complex program management is. So my manufacturing engineering experience and those of people that I work with has given me a list of 9 different reasons why program management can be complex in an organization. You'll see some things in there like time, distance, and culture, which I call the global factor, where people are trying to manage projects on different time zones around the world with different cultures. You'll see complexity due to regulatory bodies, so anything with a D or an F, like FDA, FAA, DOD, DOE, are normally complex because the government requirements are required to do so. And you'll see one at the bottom, it's never done before, companies have never done before a project before. So I'm going to deal with 2 examples today. The yellow example is an example where the company has a single, very large, almost overwhelming large project, and they can't get their arms around it with everything else going on. The other major one I'm going to deal with today and talk about is the one that's in gold, multiple projects competing for the same limited resources. So we will talk about both of these types of projects today, and I'll give you two examples of execution at the tail end of where we had high impact with both these types. So now let's define the automotive and truck capital expenditure program requirements for success. What are those requirements? If you look at this slide, you'll see a list of requirements that I've listed based on my experience doing this kind of work. In the scheduling area, there's 2 or 3 major things. The first one is the company has to be able to do dynamic scheduling. What do I mean by dynamic scheduling? Dynamic scheduling means that the schedule must be set up in such a manner that any change near the very beginning or any point during the project will change the projected project finish date. So this will allow, why is this important? This will allow time for the company personnel and management to provide a recovery. So if they know in the first 10% that they're going to have a delay in the schedule, they have the other 90% of the project to figure out how to solve the problem. So the second one is these companies all have multiple vehicle programs. And so they have to have the ability to have multiple projects all associated with different vehicle programs. So you have to have projects within programs. An example would be that most of these companies have scores of programs going on all at the same time with hundreds of projects within each program. So the last thing that's important is something that I've done in my salary career and learned it very well, and we've carried it over to helping the customers in manufacturing and engineering. And it has to do with the old axiom in manufacturing and engineering. If you cannot measure it or you cannot see it, you cannot control it. So this is all about making things visual, measurable, and where people can see things on a web application, live or almost live. And I mentioned critical path because a critical path, as you'll see on the coming slides, is nothing more than a measure of the fact that it could be it will simply identify the cause of the trouble. So those are the scheduling things that these companies need to be successful. So what are the resource management things they need? So I have about 5 items here. One of them is they have to have different kinds of work schedules. So in automotive today, has been for many years, the typical schedule can be anywhere from 40 to 65 hours per week, and that changes constantly. It depends on the demands of the business and the demands of the projects. The second thing they need to be able to do, because their operations are so vast, they cannot try to schedule man hours and reschedule separately. They have to have them integrated. So what does that mean? That means they have to have resources driving the schedule. The next item is the matter of capacity and what they decide to do internally versus externally. That's the ability to subcontract over-allocated resources on the outside. So one of the two, the most complex of the 2 or 3 game changers I'll share with you at the end of this presentation is a company that is so complex that they have a lot of their operations in the middle part of their process. About 30% on the average have to be subcontracted. Sometimes that grows to 60 or 70%. Sometimes it drops to 10%. So they have to have the ability to move tasks that are supposed to be done on the inside and planned to be from a cost and a burden absorption point of view and move them to the outside. The next one is where the project managers have to have a way to provide the resource managers with the ability in an explicit fashion how to set priorities on all these hundreds and maybe thousands of tasks. So in a typical example, this is done by a slow communication method with the project management, which seems to never work. And then the resource managers, many times when he's not left with the right information on what he should work on, he has to use his instinctive skills on what he ought to run first and what he ought to run second. The last one is every single company does this right now in automotive and many manufacturing companies, especially when they're large scale. They all produce load capacity forecasts. So their load capacity forecast consists of 2 types. They have active projects which are already funded, which they're allowed to spend money on, that might be, in the case of one of the game changers you'll see today, say 6, 7, or 8 months long. And then they also have unfunded, as far as the manufacturer, because it might be in design or approval stage, of unfunded, but a planned model launch. And so they have to have the ability to look at planned projects out on a 10, 20, 30-month planning horizon. So now, why does this industry have so many challenges that remain unsolved? If this is truly a list of what they need to run their business properly, what are they using now? What kind of problems do we typically see with these companies? So let's look at what these challenges are that remain unsolved. This slide is a slide I call the spaghetti chart. And over on the upper left, you'll see the current programs in light blue. So in the game changer example, they might have 4 programs going on simultaneously with 100 different projects and 200 or 300 or 400 dies being built all at the same time, trying to be managed and funded on an 8-month planning horizon. Then in addition to that, they have future programs. These are represented by the future programs in the lower left-hand corner. They might have 5 or 6 additional programs of 120 to 150 projects on a 24 or 30-month planning horizon. So you can see the fact that these companies try to have resource spreadsheets, text documents, project schedules, either in Excel or in Project, maybe email sometimes, and always the business system. What do they have at the end? They have no good information to integrate all this information. So the cause of the question mark is the fact they have no integration of information. So in the game changer example, the most complex one that you'll see later today, this particular company had 51 spreadsheets and project schedules, and none of which were integrated with each other, and the timing was never the same. And they spent a lot of time and effort, thousands of hours per year, and they could not make it work. So this is some of the issues that these companies face at trying to meet those requirements on schedule and resources I shared with you a minute ago. So now let's look at the types of tools that are being utilized. On this slide, you'll see 2 different categories. You'll see that 90% of the people that we work with in manufacturing engineering companies use one or both of the 2 tools here. They use Excel spreadsheets or Lotus spreadsheets, and some of them use Gantt charts. If they use Gantt charts, there's very rarely a baseline, and there's no tracking Gantt visibility ability. And they may use, typically, the ones that are somewhat more advanced will use schedules in Project. On the left-hand side on the Gantt chart, and they'll do their resources separately in a different database in Excel because Excel is so easy to use. When we encounter the problems in these companies, we also find that maybe 1 out of 20 of the people we work with will be what we call a PPM subject matter expert. Here's a person on an individual project basis that knows how to set up a project plan, knows how to create a critical path, knows how to set a baseline so they have the visibility to, if you can see it, you can control it, and also may or may not have the ability to integrate man hours and sometimes costs. So these are very advanced people, and these are people we want to pull into the process of making change to give these companies the requirements they need I outlined earlier. So now, knowing that now this is what they are using and the unresolved problems it causes is, how can technology provide the next frontier toward project management productivity, which we define as high impact? So let's look at this next slide. In this slide, we have 2 different diagrams. The one on the lower left, which is mostly black and blue, which I hope you can see those colors okay, has 2 different categories. One of them is on the y-axis called portfolio management, and one of them is on the x-axis called project management. So portfolio management, in the strictest sense of terms, is nothing more than doing the right things or picking the right projects. In the case of automotive, they're always going to have not a lot of choices, but they really do have choices in what new models they select and what kind of projects they're going to run. On the x-axis represents, once they have projects defined that are launched, is the program management operations group then must learn how to do the projects right. So what we find in most of these companies, in 95% of the cases, is to use the portfolio management tools and an EPM technology that we'll talk about here in a minute. You really have to have data. You have to have good data. Good data only happens from having an integrated project management system that allows you to run your projects efficiently. So because of that, again, in about 90 to 95% of the cases, we start the manufacturing engineering company off on doing things right by setting up a strong, robust project management system. So what are the things and technologies that are available for this new frontier in PPM technology? By the way, PPM stands for Portfolio Project Management Technology. So here we have a Gardner Research Institute study that's been conducted for about somewhere between 6 and 8 years consecutively. And they have measured what they call the magic quadrant, which is those things of the great vision and great quality of how these tools operate. And you'll see there's 6 project portfolio management quadrant leaders. And of those 6 is one that we favor a lot because we think it's one of the best of the 6. Is Microsoft. So we'll be talking about the Microsoft Project Server. We actually know for a fact from having experienced this that any one of these other tools with a good EPM solution can provide really great solutions to this complex program management world and make things simpler and easier in a vast world of many hundreds of projects and scores of programs. So now what does PPM technology for doing projects right look like? What does that look like? So I've made my own diagram here of what I think the enterprise web-based technology looks like. On the bottom, you'll see, in the diagram, you'll see 5 copies of licenses of Microsoft Project, which most people use in a standalone environment. In fact, Microsoft calls these licenses Microsoft Standard. We call it with our manufacturing engineering people standalone, because it's truly standalone. When they go to an environment where they use a web server, a SQL database, which is the yellow cylinder on the right, and the 3 major kind of reports that we'll be talking about today, they enable themselves to put all their information on the web and all to integrate it. So we'll describe what that looks like. The other major thing that's happened, this technology has been available since about 2002. So when Dr. Ibbs created his project management maturity model, this technology was not even available, so he could not have built it into his model. So I'll be showing you in some future slides what our conceptual view looks like on project management maturity for each of the toolboxes we'll represent. So the other thing that's happened here in the last roughly 2 years, the Office 365 application in the cloud now offers a very reasonable cost per month charge without a major investment of all the licenses, including maintenance, for a very reasonable price for a small to medium business. This has not been the case in the past, and the large cost of an investment has always kept the small to medium companies away from this solution of licenses. So now, how do we leverage the EPM by application solution techniques to these industry capital expenditure program and project needs? So here I'll introduce the maturity model. So here you see the first of our toolboxes. You also see an oval in the upper right-hand corner that has 5 steps on it. So we've created a 5-step model that's similar to, but quite a bit different to Dr. Ibbs, that's all based on using the technology, because that's where the power of these solutions has become. So I show in this circle on this slide a red 2, meaning that this maturity level for scheduling is a PMM level 2, the way B&W looks at this. So what are the major things in the toolbox? On a very simplified basis, we have in the box in gold on the upper left what we call dynamic schedule project families yielding troubled project forecast visibility. And in fact, the gold standard has 3 musts in it. You must have a template to collapse the drudgery of creating detailed network diagrams. And what is that? A project family is a single bunch of characteristics of what a particular project looks like, and it's always the same, so you can copy it and quickly make a change. So when we look at our game changer complex project with the hundreds of projects at the tail end, they ended up with 11 templates. And in fact, the first 2 families represented about 60% of all the projects they had to do. So they created a project plan from a template in about an hour to an hour and a half each. And each project was a cost of about $1 to $2 million, which is very, very fast for something that can be created, set a baseline on track for an 8-month period. So what does that really mean? It means in the details scheme of things that you have all the details as shown in the bottom left-hand corner, a tracking Gantt set of schedules in your Gantt chart. You have a baseline, you have an actual start, an actual finish, an actual data in the light blue, and you have remaining work either in red if it's critical path or not if it's a slack path. So you have all this information. It will truly calculate the dynamic schedule. So what is the big, huge takeaway or benefit of having this? There's actually the one shown on the lower right-hand corner. So if you look at percent of projects and tasks, let's say that you have a company that has this set up properly and they have troubled projects that are 50%. Now that seems very high, but we've had many cases where companies start out doing this and they have 40% of their projects untroubled. So this is not an inaccurate or thing to show. So let's say they have 50% of their projects are identified as troubled, the others are not in trouble. And then they have 40% on the critical path. Where'd the 40% come from? In the 33 years I've been doing this, every single project I've ever done having critical path in product development, program, facilities, and new re-engineering has always averaged 30 to 40%. The game changer particular company has a 10 or 20% rate, but I'll use 40% because that seems to be the average in manufacturing. So now they have 40% of all the tasks and the 50% troubled projects, which is only 20% of the stuff they have to look at. Then we introduce what we use, I call it the supercritical path. The supercritical path is nothing more and defined as all the tasks that have large duration. So in this one particular case, there's some complex CAM systems and die constructions that they buy that take 8, 9, 10 weeks. That's a long lead time. So that would be on the supercritical path. Other things that would be on a supercritical path would be things like a large number of man hours. So they might have some of the tasks are 100, 200, 300 man hours, and other tasks are 5, 10, or 20. So the 100 or 200 man-hour tasks would be on the supercritical path. Those tend, and it varies by business and industry, about 50%. So now the program manager, the program planning department, and the executives of the company can now say, oh, my system tells me I have 50% troubled projects. I'm just going to look at those right now. I don't have time to look at the rest. And I'm going to look at the 40% on the critical path. So now I'm looking at 20% of all the information. Oh, and only 10%, only 50% of these are on the supercritical path. So 50% times 40 and times 20 is they're looking at 10%. So these people have 5, 10, 20, 30,000 tasks. Now they're looking at 10%. It's very hard from a cultural adoption, which is picked up in the maturity model in number 2 in the oval at the top, to do this. And people struggle with not having to look at everything because that's what they've always done. So now that we understand the basics of the scheduling toolbox, let's look at 2 major things on what makes the gold standard of dynamic scheduling work. So on this slide, I just show an example of all the work we've done in the 19 years with different industries. And I'll stick here with the second 2 on the bottom portion of this slide, the product development projects and the manufacturing capital investment service providers. And these people, we're still in a program management level 2, it's still a scheduling. So what we found, it doesn't seem to matter what company we're working with, what their product is, what their process is, how good they are, how bad they are. It's very simple once you sit down and analyze the kinds of projects that are repetitive and those that are not, these kinds of families, kind of parts. So this is what the category of a template might look like. In your particular case, you might be looking at only one type of template, and you might have many different templates within that. So this explains one of the key gold standard things that you have to have is a template that summarizes what can be a fairly complicated network diagram that would always generate a critical path. So let's look at a second one. Let's take a look at I'll call it a new project management scheduling innovation for resource managers. We call it resource reports. Now, in fact, to us, this is not new. Dispatch reports are very common in production environments, and we see those in companies that are doing capital expenditure work and product launch work only in the fact they have a hot list or a priority list. So a hot list or a priority list is nothing more on this slide, web-based dispatch reports. So we created this for one of our customers. It's one of the game changers you'll see later today. And what is this? It's nothing more than a summarization by work center or by buyer of all the tasks that are still open and incomplete in any particular work center or buyer area responsibility. And what it does, it lists down the left side the project name. So in this particular customer application, you can see that the project name of the first project is a part number, a set of dies that makes a part number. 681-85637 is the part number. It has the task name. It has all the pertinent scheduling information, most of it standard fields within Microsoft Project, that shows all the things they need to know. It shows what their baseline date is, their planned start date, planned finish date, actual and remaining work. And this is very, very powerful for one reason, because what we found we could do is when we had this report recreated, which is actually created in SSRS within Microsoft and SQL. So this is a standardized report, that we could prioritize this as a default for the resource managers. And the default priority was always set the same. It involved what was the oldest order in the on planned finish date, what was the project task on a critical path or not. So that was represented in the second last column under critical path, yes or no. So yes means it's on a critical path and it's most important, do it first. And then the third one is not shown here, but the finish variance, which is only basically the difference between the planned finish date and the baseline finish date. So the priority for the finish variance was the worst finish variance. So if you had 3 tasks that were all in the critical path, the first one might be prioritized first because it had 3 weeks late to baseline. The second one might be prioritized as second because it had 2 weeks late to baseline. And the third one might be prioritized third because it was only 1 week to baseline. Now, in fact, these resource managers or buyers can open up this on the web anytime when they come into work every day and see what the latest set of requirements priorities are for them to run in their area, their department, or their work center, or their buying area. And they can look at this, and they can not only look it on the screen and print it, but they can also export it to Excel where there aren't any merged cells. And let's say they want to run item 1 and item 3 together because they can save 50 hours of setup. Well, then they can go manipulate this in Excel, and they always have the right information. So this turns out to be a very powerful solution, because what we've done is we've taken the project manager's ability, premium ability that they've developed over a period of time to use the critical path method, and now we've given that as a priority tool from critical path and finish variance to the resource manager in a very simple format that they can understand and manage. So now, how can the scheduling toolbox be the foundation for the resource management toolbox? You'll notice on this slide and the slides previous that we're at level 2. What we found over the years is that you have to manage scheduling before you can manage resources when you have them integrated. And we will take these companies to an integrated solution because of the requirements that we defined earlier. So you'll notice a 2 in the upper right-hand corner next to the scheduling toolbox on this slide. So now we're going to go to the resource tools project management box. So the project management maturity model has for it a 3, which means that's at level 3. Level 3 is the resource demand. What is resource demand? Resource demand is those requirements and man hours on the schedule to allow the schedule to be made. It is not the capacity. So what do? We work with work calendars with an overtime tool. We've actually created an overtime tool, which is a common resource capacity solution. You work more overtime when you need it, when you have overallocated resources. And since we've created a project macro that gives overtime based on various desired conditions, from what's the end date plan and how much overtime, or maybe your limit on overtime due to budgets and so forth. Then we also create generic resources in a central pool, and we use man-hour assignment, resource assignments driving the schedules. And that's all done because now we have a central database. So the key output is the lower right-hand diagram. We have a resource capacity planning tool that's called a load chart, and all these people produce these now, and it's very, very laborious way to produce it, as we shared with you in the typical methods we showed earlier. So now let's look at another new resource and over allocation innovation where critical path plays a role. So this is a diagram on the lower left and the lower right of before and after using this new technique. And although there's one way called resource leveling to use this in project, what we found, the resource leveling tool tends to take project managers away from understanding what's really going on. So we ask them more to do a little bit more the hard way. So what's the hard way, which really works? What we've noticed is in month 1, 2, 3, and 4 of the capacity forecast on the lower left, that what happens is that typically there are 2 to 3 months of overloaded resource allocations, and there's normally 1 month or more, or 1 month at the end before and after those overloads. So what we've come up with is a somewhat manual but a very effective way for the program manager to take his 40% of those critical paths, identify the ones he has the most opportunity for, and find a way to accelerate that critical path, which would normally take that project finish date and improve it from being late or maybe on time or early. And by doing that, when you look at month 1 and 2, you've seen that what they've done, they've actually leveled out month 1 and 2. And so by the same token, about 60% average of all manufacturing engineering tasks are on the slack path. So those are much more plentiful, and we have lots of choices. What we do is choose those slack path tasks that have a very large amount of threshold space between them and the critical path. So in some cases, they might have 3 or 4 days. We don't choose those. We choose those for 2 or 3, 4 weeks. So once they put this in place and things change, they can leave that solution in place for a long time and have it more effective. So normally they will do more than one slack path task, and they will move that over into month 4. So you see the result on the right-hand side is a very leveled resources. And the interesting thing about that, because we're moving some critical path project tasks and getting project finished tasks done earlier, and that we're getting some real value out of the slack path, that basically this technique for resource level loading over allocated is basically free. They don't have to spend overtime premium. They don't have to subcontract at a premium with all the cost of farming out and so forth. So this is also a new innovation on how we help our manufacturing engineering companies do their work to solve these complex projects. So now, what impact does the scheduling toolbox and resource toolbox have on doing projects right? So let's look at this slide 15. You'll notice this one shows a level 5. So a level 5 is when you get cost involved. So if you remember, we had that subject matter expert project manager be on project B. He was doing everything right and standalone. Well, guess what? Now all those things that he's helped put together, like the templates, these people are very valuable to put the templates together because they understand all this, is he's helped put the templates together. And now all the PMs, which are now project managers A, C, D, E, and so forth, all now function like subject matter experts. They all have a critical path. They all have baselines. They all are measuring their man hours, and maybe or maybe not they're measuring costs, because not everybody does that. Our game changer example, the company doesn't even look at their costs that much because their man hours, if they track all that and watch it, really controls the major part of their costs. So now, what impact does all this have on the program manager effectiveness? One of our manufacturing engineering companies actually nicknamed this, he called it the PME, the program manager effectiveness. So if you look at this chart on slide 16, you'll see again, this is a possible level 5. So in a standalone, so we have 2 views of a bunch of bars and a bunch of activities going on all simultaneously. The one on the left is standalone process of integration. And this is where companies have a single database. For those people that are trying to do project schedules, resource requirements, capacity planning, budget costs. If they're in a federal regulatory environment, they're probably trying to use earned value. They may or may not be doing master schedules. And then, so the width of the yellow shows the effort involved to do independently between all these different standalone methods to put all this data together. And even if they're able to integrate them on a timely basis, which most of them are not, you'll notice that the width of the yellow bar at all those 6 areas above total this tremendous amount of time that takes away from their actually going out and managing their projects just to put the data together so they have data to manage their projects from. On the right-hand side, you'll show that all these non-integrated things, which are separated on the left side, that are all side by side with each other, top to bottom. And there's one through thin blue line through all of them because everything is integrated together. When you add up all the blue from every one of these 6 different areas, if they do those, you'll see you have a very, very narrow blue bar on the lower right-hand side. So what we typically find that people can be successful doing any parts of this or all of this become much more efficient, and the PME results from an administrative point of view drops from 2 to 1, so as much as 2 to 1 to 4 to 1 times faster than other methods that they've used in the past. So now what evidence is there that these technology tools and methods, our applications, can actually produce meaningful results? So can these execution tools really get the job done and show real results? The answer is, if you look at these 3 examples on the high performance game changers, I have 3 companies here, which we'll discuss in more detail on another slide. You'll see we have a captive die construction plant with 300,000 man hours, and they use project management maturity level 4. They had scheduling level 2, resource demand level 2, and capacity planning and forecast level 4. And so the company on the right was a single individual project, whereas the one on the left was multiple projects. And because they didn't have all the projects and were in a hurry to manage the single big project, they had no formal forecast of what capacity was available, what conflicted with all the other projects. They didn't have the data, and they wanted to get this going to save them these tremendous amounts of time and reduction of their time to market launch, which happened to be 27%. So they only had 3 levels. What they did, we had them sit down every month, they had a review, and they reviewed all the work that was forecast coming at them with each of the individual managers. So let's say they had the chief engineer in there, the design of this new product, and he had 10,000 hour workload in the next month or 2. In the management review, he would say, well, look, I have warranty cost projects, cost reduction projects, derivative new products, and service calls to take care of. And because I have 10,000 hours, I'm going to have to give some of those up. And here's some of your choices. So the upper management would make decisions to that. So the upper management and the people doing the work were all on the same page. In the case of the small progressive die supplier in the lower right-hand corner, this was a very, very simple operation because it was only a $5 million plant with less than 50 employees, had about 5 or 10 mobile projects and 6 or 7 resources. So they had an easy time. So we only put in level 2 of scheduling with dispatch reports with EPM, and they didn't have to go to resources, and they got those kinds of gains. So now let's look at doing all the projects right, game changer comparisons. Let's compare all 3 of these and see what we see about what's unique or different about them. So if you look at this slide number 18, you will see in it you'll have each of these 3 different applications. You'll see the delta on them is 27%, 17, and 20%. What's interesting about this chart is you have completely different situations. So the top set of bars is the company that had one large global project they were rolling it out, $18 million of capital expenditure, launching at 5 plants. They used all the toolbox items except the capacity forecast, but they had very, very long lead times. If you contrast this to the other 2 multiple project examples down below, these projects were, there were a lot of multiple projects, and for example, the one in the middle had a 300,000 man-hour capacity, was $1 or $2 million projects, 5 different programs and 40 to 100 projects at a time, and medium or shorter lead time. So what this chart would indicate is that this approach seems to be extremely versatile and almost universal. And so we find that this application, the way we've developed this over the 19 years of doing this, is a very good solution to be considered for every company. And of course, the program management maturity is always unique to their organization. So now what can we conclude and wrap up about the application of these PPM technology tools and methods and practices that are achieving high performance? So if you look at our last slide, the conclusions. So you see in the upper right-hand corner, the scheduling toolbox and the resource toolbox with the different levels of maturity that each of those involve. So the first conclusion I have is that adoption and leveraging of EPM can significantly reduce the complexity of the environments and produce high impact results. The second conclusion is that developing project family templates first and using dynamic schedules and frozen baselines and critical path and forecasting and identified trouble projects, and then managing the trouble. Now that you have the trouble and you can see it, you can control it, the famous axiom, so you can manage the trouble. And the third thing is you need to have the executive management buy into a standard set of reports. We go into many different companies and many of them have scores of reports that don't get the job done. So we have found that you can be successful with these 3 or 4 standard web-based reports in the project server. So one of them, of course, is the tracking Gantt for the program manager, where he can see the slippage or on time or early or late. Another one is the load capacity forecast that everybody seems to want anyway between program managers and resources. A third one is the innovation of having a dispatch report using the CPM for the resource managers, so they can see the resources on the web every single day and get the information very quickly without overwhelming the program managers. And a fourth one that we haven't talked about today for sake of time of this presentation, because in the resource scheme of things, we have frozen baselines for budget man hours of work and plans and actuals. They also have budget man hour performance reports that are used by the program planning department, also the resource managers. We have not shown that today. So these are the 4 major conclusions we have in the presentation I've just shared with you. So with that, I would welcome your questions. So I'll let the moderator take it from here.
Yes, Ted. Thank you very much for an awesome presentation. I'm watching the chat session for questions. So far, there are none from the audience. But we have some time, so I'm going to give it a few more minutes so that they can type in their question. So meanwhile, can I ask a question of myself?
Yes.
All right. I'm specifically talking about the resource leveling mechanics in a corporate environment or in a real organizational setting. The project managers are not trained in those techniques, right? Whether they're using a scheduling tool or they're trying to do it manually. So my question is, when you go and consult with organizations, do you propose a central body taking care of leveling, or do you propose each project manager being trained?
Yes, Prasanna, that's a very good question. And the answer to that question is just what you said. From an organizational point of view, most of these companies either have or should have some type of project management office. And we find that the role of creating these load forecasts. So in the particular example I showed of the most complex project of the 3 game changers, the middle one on the second last slide, they had about 20 minutes to run the complete load forecast for both the buyers on the outside and also on the inside. So what we found the most productive way is that there normally is a specialist in the planning department that can manage and run this report and knows exactly how it works. So not all the project managers that you so aptly pointed out can have this skill, and that typically load forecasts are run at 1 or 2 times. They're standardly run at the end of every month to look at the load for the future months, so it's run once a month. But then anytime there's this very large change anywhere in the system, we encourage them to go run it again to see what's changed. But you're right, the program manager planner, who's an analyst, is quite good at doing this repetitively every month, where the program managers understand the principles but not necessarily provide that function. That's a very good question. Thank you.
And thank you for a great answer. And I completely agree with you. It seems sometimes organizations try to shoehorn project managers into something they are not, and that kind of fails, that strategy. So,
see, one of the other things that's important here, when you looked at the PME chart that I showed earlier about the effectiveness of the administrative, what the systems and the capabilities are of the EPM to do is to collapse the tremendous amount of administrative work to do this, which basically makes the program manager's job much simpler. And because of that, they're able to spend a lot more time and just look at the focus. So if you remember the focus chart in it was the slide on, I think it was scheduling, that if they have 50% troubled project and 40% on the critical path and 50% of the critical path is super critical path, although it's very hard cultural adoption to train people and their managers and companies not to go look at everything, and they will, when you put a system in, want to go look at everything till they validate the system really can do what the kinds of things that we tell them they can do when they make this commitment to execute this, is that these program managers now can focus their 10% of their time strictly on where the problems are. And it's very hard cultural adoption, which is the purpose. The cultural adoption thing I keep referring to is the thing in the program management maturity model that we build in. And I have the benefit of having more than 20 years running multiple plants and knowing how hard it is to change people thinking, get them to culturally adopt something new. So that's why we use this tool, which we really haven't explained a lot for the sake of time today, but it's a very effective way to get the cultural adoption changed. But thank you for that question.
Not a problem. It's a very common question. So I don't see any more questions in the chat window, Ted. So I guess we'll give everybody back their 15 minutes.
Okay, so if anybody has any questions afterwards, my information is available on one of the slides in this presentation. You feel free to give me an email, and I'd be glad to help you answer a question. I have a little more time to think about everything we presented today. Thank you very much for having me today, Prashant. I appreciate this.
We are thankful to have you here.
Okay, thank you so much.
All right, bye. Thank you.
Thank you.